This shirt illustrates some of my current interest in knots, in that it gives an example of a machine for producing pairs of knots coincident with the same polynomials. One of the questions, in fact, I guess the main open question in the subject at the moment is there a knot? Is there a non-trivial knot for which Vk is identically equal to 1? Well, this seems to be quite a hard problem, and as a step towards solving it, one would actually like to be able to have lots of machines for coming up with pairs of knots which have the same polynomial. Of course, it's a much weaker thing, but it's an interesting problem. And there's a method in statistical mechanics called commuting transfer matrices. And this was pioneered by Rodney Baxter. He actually used it extremely successfully. And basically, the consequence of this theory for this particular knot is, you'll notice that this knot is divided into several smaller components called tangles. So we have 6 tangles around the outside, and then 6 tangles, 1, 2, 3, 4, 5, 6 on the inside. And these tangles are connected to each other by this framework. And then there's some way of closing them off on the inside and the outside. This way of closing them off actually corresponds in physical terms to boundary conditions. And the result of this commuting transfer matrix analysis is that if I took these outside tangles and I interchanged them with all of the inside tangles, so I'd just do a reversal between this one and this one all the way around, then those 2 knots would have the same polynomial. So for what it's worth, that's the result. But it's actually turned out to be quite flexible, because by varying these tangles and varying the boundary conditions, you can actually get a lot of examples of pairs of knots with the same polynomial.